Good morning, children. So, this is the unit about magnetism and electromagnetism. ஸோ எலக்ட்ரிசிட்டிக்கும் மேக்னெட்டிக் ஃபீல்ட்ஸ்க்கும் என்ன ரிலேஷன் இருக்குது அப்படின்றத இந்த யூனிட்டில் நம்ம பார்த்துட்ருக்கோம். ஸோ லாஸ்ட் கிளாஸில் பார்த்தோன்னா ப்ராப்பர்ட்டிஸ் ஆஃப் மேக்னெட்டிக் லைன்ஸ் ஆஃப் ஃபோர்ஸ் பார்த்தோம். தென் சர்க்யூட் கனெக்ஷன் இருந்துச்சுன்னா ஹவு த மேக்னெட்டிக் ஃபீல்ட் இஸ் ப்ரொடியூசிங் வென் த எலக்ட்ரிக் கரண்ட் இஸ் ஃப்ளோயிங் த்ரூ தட் அப்படின்றத நம்ம பார்த்தோம். ஸோ லாட்ஸ் ஆஃப் திங்ஸ் நம்ம டிஸ்கஸ் பண்ணிட்டோம். ஸோ லாஸ்ட் கிளாஸ் நம்ம ரைட் ஹேண்ட் தம் ரூலோட நம்ம கிளாஸை கன்க்ளூட் பண்ணிட்டோம். Okay, and today we are starting our class with the point 5.4, force on a current carrying conductor in a magnetic field. Force on a current carrying conductor in a magnetic field. So this concept, it came from Lorentz experiment. The scientist Lorentz, H.A. Lorentz, he found that whenever the charge moving in a magnetic field, so note பண்ணிக்கங்க, the charge is moving in a magnetic field. It is not a resting charge. The charge should move எங்க in magnetic field. That charge will give some force. It is having some force. Meantime, the charge should be perpendicular to the magnetic field. அப்போதான் அதோட ரிசல்ட் இன்னும் பெட்டராக இருக்கும். If it is parallel or anti-parallel அப்படின்றப்போ the force will be zero. புரியுதா? So the charge is giving maximum force when it is moving perpendicular with the magnetic field. Okay, this is main concept. So based on the concept, this topic is explaining the force on a current carrying conductor. Okay, and see here figure 5.7 is given the magnet, Hertz magnet is given. The red color is north and blue is south pole. North south irundale the magnetic lines of force always will flow from north to south. Same concept we can give for earth too. நம்ம earth எடுத்துக்கிட்டாலும் நம்ம earthலையும் 4 டைரக்ஷன் இருக்கா, நார்த் ஈஸ்ட் வெஸ்ட் சவுத். இந்த நார்த் ஈஸ்ட் வெஸ்ட் சவுத்லேருந்து நம்ம நியூஸ்ன்ற வேர்டு எடுத்துக்கிட்டோம். அது உங்களுக்கு எல்லாம் தெரியும்னு நினைக்கிறேன். ஸோ நார்த்தோட ஃபஸ்ட் லெட்டர் என், ஈஸ்டோட ஃபஸ்ட் லெட்டர் இ, தென் வெஸ்டோட ஃபஸ்ட் லெட்டர் டபிள்யூ, தென் சவுத் எஸ். இந்த ஃபோரும் கம்பைன் பண்ணி வரதா நியூஸ். ஓகே, அதான் நம்ம நியூஸ்னு சொல்கிறோம். ஓகே, அண்டு இப்போது நார்த் சவுத் எடுத்துட்டோன்னா தீஸ் டூ ஆர் ஆப்போசிட். எது நார்த் எது சவுத்துன்னு உங்களுக்கு நல்லாவே தெரியும். ஸோ நார்த் சவுத் இருந்தாலே ஹவு த மேக்னெட்டிக் ஃபீல்ட் வில் ஆக்ட் ஃப்ரம் நார்த் டு சவுத். இட் ஸ்டார்ட்ஸ் ஃப்ரம் நார்த் அண்ட் எண்ட்ஸ் அட் த பாயிண்ட் ஆஃப் சவுத். அப்போது நம்ம எர்த்துக்கும் மேக்னெட்டிக் ஃபீல்ட் இருக்கான்னா டெஃபினெட்லி எஸ், there is a magnetic field. It is a huge magnet, but it is a weak. மற்ற நம்ம யூஸ் பண்ணுற ஆர்டிஃபிஷியல் மேக்னெட் மாதிரி ரொம்ப ஸ்ட்ராங் கிடையாது. இட் இஸ் வீக் அண்ட் இட் இஸ் ஆல்வேஸ் வில் பி தேர் நார்த் டு சவுத். அதனால தான் நம்ம தூங்கும்போது நார்த்தில் தலை வச்சு படுக்கக்கூடாதுன்றாங்க. ஓகே, அப்படி நார்த்தில் தலை வச்சோன்னா த மேக்னெட்டிக் ஃபீல்ட் மே அஃபெக்ட் அவர் பிரெயின். ஒரே நாளில் இது நடக்காது. இட் வில் டேக்ஸ் டே பை டே. ஸோ டே பை டே கொஞ்சம் கொஞ்சமாக நடக்க ஆரம்பிச்சு இட் வில் அஃபெக்ட் அவர் பிரெயின் தாட்ஸ் ஆல்சோ. அதனால தான் இந்த ரீசனாக தான் சொல்கிறாங்க. இதை வேணால் உங்கள் பெரியவங்கிட்ட டிஸ்கஸ் பண்ணிங்க, இல்லை நம்ம ஸ்கூல் ஆரம்பிச்சதுக்கப்புறம் கிளாஸில் டிஸ்கஸ் பண்ணிக்குவோம். ஓகே, அண்ட் நவ் ஹியர் ஒன் ஆக்டிவிட்டி. we are taking the cardboard and we having the current carrying wire, and near to that current carrying wire is better we have compass. Okay, here magnet கொடுத்துருக்கேன். we can use magnet or compass. So compass will give good result here. So compass near to the current carrying conductor நம்ம வச்சுட்டோன்னா this compass will shows the reflection. ஸோ ஒரு பர்டிகுலர் பாயிண்டில் ஒரு ரிஃப்ளெக்ஷன் ஷோ பண்ணிட்டு இட் வில் பி ஸ்டாப்ஸ். அந்த பொசிஷனில் என்ன டைரக்ஷன் கட்டுதோ வி கேன் கீப் அ டாட். அதே மாதிரி வேரியஸ் பொசிஷனில் அரௌண்ட் த கரண்ட் கேரிங் கண்டக்டர் இஃப் வி கீப் அ டாட் அப்படின்றப்போ வென் வி ஆர் ஜாயினிங் ஆல் த டாட்ஸ் டுகெதர், அந்த ஜாயின் ப்ரீவியஸ் டாட்ஸை பேஸ் பண்ணி நம்ம காம்பஸை பொசிஷனில் வைக்கும்போது இட் கிவ்ஸ் சம் ஷேப் அண்ட் திஸ் ஷேப் எக்ஸ்பிளைன்ஸ் த மேக்னெட்டிக் ஃபீல்ட் லைன்ஸ் விச் இஸ் ஆக்டிங் யூனிஃபார்ம்லி. Okay, so in the current carrying conductor there is no magnet, but even it's showing the lines of force of the path with the help of that compass, and it is more clear. It is also acting like a bar magnet. So in the effect நம்ம எங்க எக்ஸ்பிளைன் பண்ணலாம்னா பார் மேக்னெட் வச்சு தான் எக்ஸ்பிளைன் பண்ணுவோம். பட் இங்கே பார் மேக்னெட் யூஸ் பண்ணாமையே நம்ம current carrying conductor வச்சு explain பண்றோம். So this is called as effect of current carrying conductor. Okay, so using the compass we can draw that, and here it is given. See, these lines are given very clear how the magnetic field. So in the magnetic line, suppose எங்க start ஆகும் அப்படின்னா from north polarity and it ends at the south. So from this we can say whenever the electric current is flowing through the conductor, that conductor around that which is exhibiting like a magnetic like property. So I current is flowing in that conductor means it produces B magnetic field. Say the length of the conductor which we are using, and the conductor length L னு எடுத்துக்கிட்டோம்னா எவ்வளோ ஃபோர்ஸ் அது கொடுக்கும் அப்படின்னா we having a formula BIL or ILB formula it will be produced. Okay, so it is along with the sin theta. இது இங்கே டிஸ்கஸ் நம்ம பண்ணலை லோவர் கிளாஸ்ன்றதுனால. About this we'll discuss in higher class. Higher class இதை பற்றி நம்ம டிஸ்கஸ் பண்ணிக்குவோம். So already I told, when the charge is perpendicular to the magnetic field, then only its effect will be a maximum. Okay, whether it is parallel or anti-parallel, its effect will be very very less, or we can say even zero. Okay, and so with the help of angle we can find out the final answer BIL sin theta, and we can say this is BIL here. Okay, so this rule we can explain the direction of force with the help of magnetic field and current can be explained with the help of Fleming's left hand rule. So the help of Fleming's left hand rule. Okay, so it is explaining very clear how the direction of force will be. So for that we have to stretch our 3 fingers of left hand's thumb, fore and middle finger, all 3 are perpendicular to each other. So in that case the rule is, it was explained by the scientist Fleming. As per rule we can say the forefinger showing the direction of magnetic field, and the middle finger will shows the direction of electric current, and thumb it represents direction of motion of conductor, or we can say force also. So we can say it is acting, it is giving the direction, thumb is motion, forefinger is magnetic field, and middle finger is what? Current. So using that we can explain that very clearly. This is called as Fleming's left hand rule. So this rule only we are using when we are knowing magnetic field and current, and if we want to know the motion of the conductor means we can use this rule. Okay, and now so based on this topic here we having 2 problems. Problem number 1, a conductor of length 50 centimeter. So centimeter abdin vandale will convert that centi into meter. So what is the centi value in meter? 10 power minus 2. Carrying a current of 5 ampere, it is placed perpendicular to a magnetic field of induction 2 into 10 to the power minus 3 Tesla. Find the force on the conductor. They are asking to find out the force. So we are having formula for force. F is equal to BIL or ILB. We are substituting all the known terms. Then we are solving. We got the answer 5 into 10 to the power minus 3 Newton. And next is problem number 2. So the question is, a current carrying conductor of certain length kept perpendicular to the magnetic field experiences a force F. And question is, what will be the force if the current is increased 4 times? So we are increasing the current by 4 times. The length is halved and magnetic field is tripled. The length வந்து நம்ம half பண்ணி magnetic field triple பண்ணிடுறோம். Then we can get the answer formula F is equal to ILB. The length is increases to what? Half. Sorry, decreases. And the current is increases by 4 times. Then magnetic field is also increased by 3 times. Then we are substituting I is equal to 4I, L is equal to L by 2, and B is equal to 3B. We are solving all this. The answer will become 6F. Therefore, the force increases for 6 times. Okay. And next is force on a parallel current carrying conductor. So here we will see the effect of parallel current carrying conductors. So for this we need 2 conductors which is parallel to each other. And see the figure 5.10. 2 conductors are there. first and second conductor is given in blue color. And now say these two conductors are infinite length of conductor. It is connected with the two ends of the battery source, or two different potential. So after connecting here, we are passing the electric current through the two conductors. So the first conductor carrying the current I1 is acting on direction, and second conductor carrying with the current I2 which is acting same direction, and these two conductors are little close to each other. At the time these two conductors carrying the current, these two conductors are experiences the magnetic field. So this magnetic field, so current is there, the charges are flowing, there is a current carrying conductor around that conductor there is a magnet. In the two point நம்ம எடுத்துக்கிட்டோம்னா, here it gives the force, and these two forces are attracting to each other. So these two conductors are attracted to each other. The same concept we can explain by changing the direction of current in any one conductor. For example, see in second half in this picture. So till now I explained this first one, and now I am explaining the second one. The same concept. In second conductor, the current is reversed. The current is in opposite direction. And comparing to both the conductors having the opposite direction of current. Now the same concept, there is a magnetic field. Electric current is flowing. These two are separated by some distance. And these two conductors producing force. That force we can explain with the help of Fleming's left hand rule. Fleming's left hand rule which எப்படி explain பண்ணலாம் அப்படின்னு கேட்டா, we have to keep our fingers like a direction of magnetic field and current. Okay, like a magnetic field and current. So using that, we are giving the direction of force, and when the currents are in opposite, then we can say these two conductors will repulse to each other. அப்போ ரெண்டு கண்டக்டரும் சேம் டைரக்ஷனா இருந்துச்சுன்னா these two are attracting, and if the two conductors having the current in opposite direction means these two are repulsed. Once again I am repeating you, and this repulsion of force can be identified, can be found with the help of Fleming's left hand rule. So that is given very clear in the figure 5.11. So the current carrying conductor, how it gives the attraction repulsion, it is given in this figure. And so here we can give the connection between electricity and magnetism very clearly based on this topic. Okay, so before 18th century, the people thought magnetism and electricity were separate. Till 18th century they thought like that. After the Oersted experiment, electricity and magnetism were united and become single subject, that is called as electricity plus magnetism is equal to electromagnetism. So when there is a current, the magnetic field is produced and the current carrying conductor behaves like a magnet. Okay, this is possible, and this possibility can check with the help of compass or magnetic needle. Okay, as results of magnetic field in natural magnets and artificial magnets that we buy in shops, the electrons move around the nucleus constitute a current, which leads the magnetic property. Here every orbiting electron, it is revolving around the nucleus, it creating some current. And if there is a current, if there is a flow of current, that value is very small, very feeble. If there is a flow of current, we can say definitely some magnetic field will be produces there. Okay, and now we can say the motion of electrons only will cause this. If the electrons are not moving means there is no production of electric current and there is no production of magnetic field. So when the electrons are revolving around the nucleus and around the nucleus gets added up, and as a result we can find the permanent magnet of the single material. So evlo electrons, evlo atoms irukko ellathiyum add panni the total effect will be executed in outside of that material. Okay, this is called as about electricity related with the magnetism. Okay, and now the topic is electric motor. It is important topic. So about the electric motor device, we know that very well. This electric motor is functioning in the basis of electric energy is converting into mechanical. So electric is converting into mechanical. So electric motors are very crucial in modern life. Everywhere we are using, in car, bike, for pumping water, and juicer machine, grinder, mixing. So everywhere we are using this electric motor. So here we will understand how the electric motor is functioning. So what rule and what effect we are using here, we will see here. So in this, the principle used in this is electromagnetism. That method is used here, and due to that force, magnetic field and current, it creating some turning effect. The turning effect is converted into what? Mechanical effect. Okay, and see the picture of electric motor. So two magnets will be there, both the sides. சின்ன மோட்டார் நம்ம எடுத்துக்கிட்டோம்னா we can use permanent magnet. If heavy motor, ஹெவியாக நம்ம யூஸ் பண்ணும்போது we can use the electromagnet. Okay, electromagnet ரெண்டு சைட்லையும் நார்த் அண்ட் சவுத் போல் ஆக்ட் ஆகும். Whenever the electricity is passing through that material, it produces magnetic field. When we switch off that, there is no magnetic field production. Okay, heaviயாக இருக்கும் அந்த மாதிரி நம்ம யூஸ் பண்ணுவோம். And middle we having the armature, and here it is named ABCD. Okay, ABCD armature is there. This armature is rotate. This rotation will cause, ஏன்னா electric field magnetic field மாறணும்னா it should be changed. The charge should be flow. Restல இருந்துச்சுன்னா it won't flow any, it won't give any result. It should rotate. So for each and every movement, it gives the mechanical energy. For example, say the current carrying conductor segment AB, the direction of the current is towards B, whereas the conductor segment CD in the direction of opposite. So when AB is one direction, means their opposite will be opposite. So here the direction of motion can be explained with the help of Fleming's left hand rule. If the current is flowing along the ABCD means, and this armature is won by the number of turns of the coil. நம்ம motor open பண்ணி பார்த்தாலே தெரியும். More number of turns of the copper wire will be there. Say this armature is revolving or rotating in the clockwise direction. Sorry, not revolving, it is rotating in a clockwise direction, and the current should be applied ABCD for first rotation. So it comes next side, it will be reversed, that is called as DCBA. This is because of commutator. Okay, the commutator is used here as a split ring. This split ring only is giving here in this moment. The gap of split ring commutator is aligned with the terminals X and Y. There is no flow of current in the coil, and the coil is moving and continues to move forward, bringing one of the split ring commutator contacting with X and Y. That is called as carbon process, and this process will be continue. So till that it will be rotate, and the direction of current will be reversed. So next half the current will become DCBA, direction will become as ABCD, then again DCBA, then again ABCD, it will be happens. It is converting into mechanical energy. So we are pumping water, and for various purposes we are using here. And this motor, speed of rotation of coil can be increased. So if speed of coil increases, its efficiency is also increases. In four ways we can do this. One is we can increase the strength of the coil. So we can add more number of turns of the coil. If more number of turns of the coil, its efficiency will be more. Or increase the number of turns of the coil, then increasing the area of the coil, then increasing the strength of the magnetic field. So both the sides we are having north and south polarity now. When we are increasing the strength of that, we can increase the speed of rotation. The speed of rotation is vary, the effect of that motor is also vary. நம்ம நிறையவே கேள்விப்பட்டிருப்போம். நம்ம வீட்டு கனெக்ஷன்ஸ்க்கெல்லாம் வாட்டர் பம்ப் பண்ணுறதுக்கு 0.5 HP, 1 HP, 1.5 ஹெச்பின்லாம் யூஸ் பண்ணுவோம்ல. ஸோ ஹெவி போர்வெல்க்குலாம் பார்த்தோன்னா 11 HP, 8.5 ஹெச்பின்லாம் நம்ம யூஸ் பண்ணுவோம். ஸோ தட் இஸ் based on these 4 points. நம்ம ஸ்ட்ரென்த் ரொம்ப க்ளோஸராக போடுறது, நம்பர் ஆஃப் டர்ன்ஸ் இன்க்ரீஸ் பண்ணுறது, அதே மாதிரி ஏரியா ஆஃப் த கையில் இன்க்ரீஸ் பண்ணுறது, then increasing the strength of the both the sides magnetoட produce பண்ண magnetic field increase பண்றது. These are all the methods, some ideas how to increase the strength of or efficiency of the electric motor. Okay, okay children, we'll stop our class up to here. And today's homework, you take about electric motor. So electric motor answer is starts from this topic as electric and up to before the 5.7 magnetic field. Okay, so in the idhula oru diagram mattum podum, don't want these two diagrams. So thorough this, then write in your homework part, then you send the images to my personal WhatsApp number. Okay, thank you children, and rest of the class will discuss in our next upcoming classes. Okay, thank you.